Welcome to the Colorado RiverWatch Macroinvertebrate Collection Instructional Video. In this video, we will demonstrate the collection techniques the RiverWatch program uses to sample for macroinvertebrates. Macroinvertebrates are insects that are visible with the naked eye. In rivers, these organisms live on the bottom and in between and under the substrate. The macroinvertebrates that live in our streams are used as bioindicators to help assess the health of a water body. Our primary objective for collecting macroinvertebrate data is to compile a species list over time and space to identify missing, additional, and indicator species that might signify changes in the aquatic environment. One reason we study macroinvertebrates is to monitor invasive species. The New Zealand mud snail is an exotic species that has recently been discovered in Colorado along the South Platte River below 11 Mile Reservoir and also in Boulder Creek. These invasive species are outcompeting native organisms for food and habitat, thus upsetting the balance of the river ecosystem. We must take care to stop the spread of these invasive species by thoroughly cleaning waders and equipment. Use a 50-50 mix of Formula 409 and water to thoroughly clean gear after working in the affected areas. All right, guys, let's talk a little bit about the equipment that we need to sample macroinvertebrates. Most important, we need our net, okay? This is called a modified D net. We're also gonna need 2 different buckets, a brush, tweezers, a tub. White tubs work best.
Why white tubs instead of black tubs?
We need white tubs because when we put macroinvertebrates or our bugs into them, we'll be able to see them much more clearly with a white tub as the background. If we're using a dark tub, a black tub, we wouldn't be able to see the insects very well. We're also going to need a sieve and our collection bottles that RiverWatch has sent to us previously. When sampling for macroinvertebrates, it's best to use a team approach. When all team members understand their role prior to arriving at the sampling site, your sampling event should run smooth. A macroinvertebrate collection team would likely consist of a timekeeper, kicker, net holder, and data recorder. When sampling macroinvertebrates, try and sample all the other water quality parameters at the same time: metals, nutrients, and all your field parameters. Getting all this data at one time collects a broader picture of what's happening in the stream at that exact moment and is better for us to make decisions upon your data. When selecting your site, there's a few things to consider. First, we want to be relatively close to our normal water quality sampling location. Our sampling site also chronicles the area that is 100 foot below and 100 foot above your site. So pick an area that has good access, that you can measure the various physical habitat features and also be able to wade through that area to collect the macroinvertebrates from the various kick sites that you collect. Think safety. Do not go into an area that is too swift or too deep for you to maneuver. Safety is top priority. We also want to make sure that we are at least 100 feet away from any bridges, obstructions, sewer outfalls, and other man-made materials that may alter the physical habitat of the stream. These things you must keep in mind when selecting a sampling site. Now that we have selected our sample location, we must determine if the river bottom, or substrate, is rocky or sandy. The river bottom type will determine what collection method we will use. When determining if your site is rocky or sandy, consider the following. Is your sample site covered by rocks and other hard-bottom substrate, or is it more sand and silt? If your site has more than 50% sand and silt, it is a sandy site. If your site is more than 50% rocky substrate, your site is rocky. Once you have determined whether your site is rocky or sandy, it's time to map your site. Use page 1 of your macroinvertebrate collection data sheets, the sample site information and depth profile sheet, to illustrate your map. The map will help us identify your site should we need to come back to it at any time. Highlight any important features that will help us identify exactly where your site is. Draw on any stream attributes such as riffles, dams, fallen trees, pools, roads, pipes, and other landmarks to identify the reach. You will also need to indicate where you have taken your composites samples from. If you are using a kick method, draw a square over each riffle that you had sampled for the kick method. Now we need to record our average depth profile. In this section, what we needed to understand is how deep the water is across the stream. So you'll be making a transect, which is a lateral line that crosses the stream. At 1 foot increments, take your measuring staff and record how deep each measurement is. Once we finish taking all our measurements across the transect, we need to average these numbers. Add them all together and divide by the number of measurements you've taken. After we have calculated average depth from the measurements we took across the stream transect, record that measurement to the lower right-hand corner of the physical habitat datasheet. If you have determined your site to be rocky, move to the next chapter that details rocky substrate sampling methods. If you have a sandy substrate site, skip the rocky section and proceed to the sandy substrate collection method. In the RiverWatch methods, what you're doing is actually making a composite sample. A composite sample is a sample that is comprised of many different subsamples. In our macroinvertebrate technique, there are 4 different subsamples that respond to the 4 different areas that you're sampling. It's important that you know that you're not going to remove the materials from the net until you've sampled all 4 areas. For this method, we need to sample in 4 locations. We need 2 slow-moving riffles and 2 fast-moving riffles. A fast-moving riffle is where water is moving between 1.5 and 2.5 feet per second. It's usually a little bit of white water. A slow-moving riffle is anything that moves between about 0.5 to 1.5 feet per second. Remember, you need to sample in 2 fast riffles and 2 slow riffles. Move to the most downstream riffle for your first kick. Your kick area will be a 3 foot wide by 5 foot 5 inches long rectangle. Measure your net prior to sampling and mark a length of 5 foot 5 inches on your net handle to remind you of the proper length. Measure the kick area at the riffle you will sample by laying the net down and making a mental map of this sample area. Inside this rectangle will be the area you will kick. Once your data recorder has labeled the kick number and whether you are sampling in a fast or slow riffle, it's time to kick for bugs. Begin your kick by placing the net in the water on the bottom of the stream. Once your timer calls out for you to begin your kick, the kicker begins by using their toe and heel to disturb, dislodge, and uproot the upper layer of substrate. Begin at the upstream portion of the kick area and move down towards the net. Do not kick the larger substrate out of the way. Larger rocks or debris, such as logs, vegetation, and even trash, should be picked up and brushed immediately upstream of the net so bugs will flow into the net. The goal is to get all of the bugs and smaller debris from your kick area to flow into the net. Aside from collecting the macroinvertebrate sample, we also need to detail the habitat of the kick area that's being sampled. Use this data sheet to record that habitat information. When recording data, it's important to understand whether or not we're sampling a fast riffle or a slow riffle. In this example, we have a slow riffle. We'll circle that. We now need to go and describe the substrate type. The substrate seeks to describe what kind of rocks, sand, gravel, boulder is actually on the stream bottom. Take your ruler and measure what is actually there. Boulders are any rock or large piece of debris that's larger than 10 inches. Cobble ranges from 2.5 to 10 inches. Gravel goes from 0.1 to 2.5 inches. Sand is much smaller, below 0.1 inches. Silt is a very fine sand, and clay is also even much more fine and is often slick, slimy, and gray. The kicker estimates the percent of each substrate size, and the recorder records the estimate in the appropriate box. For this kick area, the inorganic substrate composition is 30% boulder, 10% cobble, 50% gravel, and 10% sand. Added together, these numbers must equal 100%. Now use your measuring stick to measure depth at 4 locations within your kick area. Average these recordings to get average depth. Once we have the average depth recorded here in column 2, our depth, again, make sure to record what units you're recording in. In here, we're using feet and inches. We also need to understand if there's any organic substrate within our kick area. Organic substrate are fallen logs, leaves, things like this. Not rocks, not sand, not inorganic components. In this kick area, there is 0 organic debris. Put zeros in every column. Now that we have recorded all the kick area information, pick up your net and move to the second of the 4 kick locations. When picking your net out of the water, it's important for you to be careful not to lose any of the sample or debris. Pick the net up gently and use the water to shake that sample down into your net. Do it 2 or 3 times in order to get all your sample down into your net, and then move to the next sampling location. When you've moved to your next sampling location, put the net down gently in order that you do not lose any debris or material from your net. Repeat the kick technique and substrate data recording in your 3 other locations using a new substrate composition data sheet for each location. Okay, in sandy substrate, we have to use different techniques to find the macroinvertebrates that live in this kind of habitat. To find the insects that live in sandy bottom streams, we have to sample less of the substrate bottom itself and more of the different kind of habitats that surround the substrate. For example, we're going to be sampling areas that have vegetated banks, overhanging vegetation that dips into the water, any snags or debris that's in the water. We'll also be spending time sampling the water column itself, and we also will spend some time sampling this river substrate. The sampling method here calls for a total sample time of 4 minutes. So we're going to take the amount of different habitats we have, divide that by the 4 minutes, and spend that amount of time per each habitat. For example, if we only found 4 different habitats, a snag, a sandy substrate, a water column, and an overhanging bank, we'd spend 1 minute on each habitat sampling that particular area. Measure your net prior to sampling and mark a length of 5 foot 5 inches on your net handle to remind you of the proper length by laying the net down and making a mental map of this sample area. Inside this rectangle will be the area you will kick. Here you want to prod and disturb the debris as much as you can. Remember, work from downstream to upstream to allow the water current to carry any insects you dislodge into the net. When sampling the sandy substrate bottom, work from the top of the sample area down to the net. Work down throughout this whole area, dislodging all the sediment that's in there. Many macroinvertebrates won't be found here, but we still will find some. Scrub down any large debris you find. This way you'll be sure to include any macroinvertebrates that may be living on the surface of detritus, large rocks, litter, or any other large product that won't conveniently fit into the macroinvertebrate sampling net. Backwaters and eddies are also good habitats to sample. These are areas that are unique in the habitat and may offer some interesting macroinvertebrate species. As this is a composite sample, all the different habitats you sample will be collected in the net together. You will not be removing each sample's worth of debris and macroinvertebrates as you move along. Collect all the different samples, all the different matter that you collect through each habitat in one net. As you lift the water out of the net, be careful that you don't lose any of the debris or matter that you've collected. Shake the debris down using the water current to push all the debris and matter down into the bottom of the net. As we sample these sandy habitats, we also need to make note of what kinds of habitats that we've been sampling. For this, we're going to go to our substrate composition data sheet. For sandy habitats, what we're really concerned about is column number 3. We need to identify what kinds of habitats that we've been sampling, how long we've sampled each habitat, and the percent composition of each sample. So for 5 samples, for 5 different habitats, we're going to sample 48 seconds each. We also need to understand if there's any organic substrate within the habitats that we've sampled. Describe any sticks, wood, coarse plant material, any muck or marl, which is this black, very fine organic material. Describe what percent of each is in the sample. This may not equal 100. Once the sample is collected and composited from all sample habitats and locations, gather the sample material into one corner of the net. Fill the bucket 1/2 to 2/3 full of stream water and turn the net inside out into the clean sample bucket. Knock or wash any obvious macroinvertebrates, debris, algae clumps, or masses into the bucket. Examine the net closely for organisms that may want to stay behind. Pluck these organisms off with forceps and place directly into the sample jar. Look in the bucket for large rocks or debris that you can handle, such as bare twigs or leaves. Pick them up one at a time. Pluck the organisms off with forceps and place them in the sample jar. Do not rinse over the alcohol-filled sample jar. With your bucket half full of water and sample material, prepare to swirl. Turn your bucket in this swirling motion to separate the lighter material and bugs from the heavier sediment. The bugs and light debris will float to the top. Swirl for 20 seconds and then pour the sample debris and bugs into the sieve. Carefully place all the organic material and bugs from your sieve into your sample jar. A specialist will later separate the bugs from the debris during analysis. Do not attempt to pick the bugs yourself. Just place all the organic material into the sample jar. If you have been selected to collect a quality assurance sample for the macroinvertebrate protocols, you need now to gather all the substrate and any discarded debris that you've collected throughout your sandy substrate collection and put it into the extra bottle that's been provided for you. We do this so that an analyst can, again, review the substrate that you've collected and make sure that the insects are not there and that you have been successful at picking all of them out of the material. Mark this area on your macroinvertebrate data sheet if you are submitting a quality assurance sample. Label your sample and any other QA samples you may have accordingly with the magic marker on the outside of the jar. Include sample number, station name, date, and time. Fill out a paper label in pencil with the same information and place this paper label into the sample. The inside label is smaller and requests the collector's name. Later that night, after you've collected the sample, you will need to decant the alcohol that's in the sample. Decanting is removing approximately half of the alcohol that's in the sample and then adding fresh alcohol. When you decant the alcohol that's currently in the bottle, you remove the excess water that's been collected with your sample and replace that with fresh alcohol. Fresher alcohol will mean the bugs will be preserved longer. Ship or deliver the sample within 2 weeks of collection. Include all data sheets and chain of custody. There is a spot on the chain of custody for bugs, which is also downloadable on our website. Complete a field data sheet to go with the macroinvertebrate and physical habitat data sheets. Include all water quality data that was collected and keep a copy of the data sheets for yourself. Part 4, Entire Segment Physical Habitat Description. This section evaluates habitat features, watershed features, localized erosion, riparian vegetation, aquatic vegetation, and in-stream features for the entire 200 segment you have mapped in Part 1. It is important here to consider the entire 200-foot segment when answering the following physical habitat questions. First, walk the entire segment length with your colleagues before completing the assessment. To understand what is being assessed, let's break down the data sheet row by row. Section A, Habitat Feature Descriptions. This item describes all the different habitat types within your 200-foot segment. Carefully evaluate each habitat feature independently and estimate the percent of each feature as it is found in the segment. For example, a high gradient mountain stream may have 90% or more cobble. Also consider snags and other woody debris, vegetated banks, and sand in the substrate. Section B, Watershed Features of the overall area. This is a description of the land adjacent to both the left and right stream banks. Always determine left and right bank by standing in the stream and looking upstream. Left banks will be on the left, right banks are on the right. For each bank, check the predominant top 1 or 2 most prevalent type land uses 300 feet adjacent to the reach. Some example land uses are forest, field, industrial use, and dense housing. Section C, Localized Erosion of the overall area. This section evaluates local erosion and potential sources of sediment in the stream reach. In this section, there are 3 parameters to note. The first parameter is bare bank soil. Make an estimate of the area of bare soil in the riparian zone that is not bound by plants and their root structures, nor covered in concrete or rocks. Section 2. Erosion amount. This estimates the amount of erosion that is present on the banks within the reach. Choose the category that best describes your estimate. Section 3. Bank movement and stability. Due to lack of vegetation, roots, or other mechanisms to keep the soil in the bank from entering the water, the banks may have become unstable and shown signs of degradation, such as in this photo that shows bank failure. Section D. Riparian vegetation of the overall area. The riparian zone surrounding a stream or river is defined as the vegetation community that grows from the water's edge to where a different vegetation community begins. In this example, we see a riparian zone of birches and willows, ending where the different juniper and oak community begins. In this section, please describe the predominant vegetation type for each bank. You don't need to know the species, just the type, such as tree, grass, shrub, or forb. Now we need to measure the riparian zone width on both banks. Use your tape measure to measure the riparian zone from the water's edge to the end of the riparian zone. Section E. In-stream aquatic vegetation of the overall area. This section focuses on vegetation in the stream only, not on the banks. Is it a rooted floating plant, which is a rooted aquatic plant that has came loose and is now floating freely? Is it submerged floating leaf variety, which are rooted within the stream and that have leaves that float in the water column or on the surface? Is it attached algae? This is most commonly referred to as the slick moss that occurs in mountain streams throughout Colorado. Do not confuse an algae with true moss that is not an aquatic plant. The last choice you have is whether or not you have any free-floating plants that float in the water as they grow. Examples of this are duckweed and water hyacinth. Consider the entire 200-foot reach as a whole. What percent of that reach contains any of the aquatic vegetation types we have just described? Section F. In-stream features of the overall area. This section evaluates in-stream features that provide quality habitat for macroinvertebrates. Again, evaluate this for the entire 200-foot stream reach. First, estimate the amount of canopy cover that overhangs this stream bank and that causes shade to fall on the stream. Look up and down the stream. If the tree canopy covers the entire width of open water, the canopy cover would be 100%. Next, fill out the stream reach description. Pools, which are slow deep water, riffles, which is fast shallow water, or runs, long, deep, slow gliding pools, are the descriptors used to identify how the stream is moving through space. Identify the percentage of each type in your reach and note. Added together, these numbers must equal 100%. In Section F, in-stream features, we're seeking to understand the stream width. There's two widths that we need to understand in this feature. One is the wet water width. So we're actually looking to understand how wide is the stream from bank to the water's edge, from the right bank to the water's edge to the left bank. Take that measurement by exactly putting it down where the water touched the bank at both ends. In the measurement we just took, we had a wet water width of 21 meters, 10 centimeters. The next width we need to record is the estimated bank full width. Here we need to understand where the water normally rises to at bank full stages, at flood stages. Look at your banks. You can normally see a small shelf a little higher than the wet water width that indicates where the high water has come, and the high water has then etched that table, that shelf out along the bank. Take a measurement from that bank full width from the left and right bank and record it. Here we had a estimated bank full width of 27 meters and 15 centimeters. It's important to note what measurements, what units you're using when recording these measurements. Are you using feet? Are you using inches, centimeters, or meters? Be consistent when filling out the entire data sheet. If all your measurements are in feet, put them all in feet. If all your measurements are in meters, list them all in meters in the metric form. Flow is a measurement of how fast the water is moving through the stream. Discharge is a measurement of how much water is moving through the stream. To measure both flow and discharge, we use a floatable object like a wiffle ball and a tape measure. For this technique, we're going to mark out a specific length of stream, approximately 5 feet. Then we're going to release the ball at 0 feet and time it as it moves along the stream till it gets to the endpoint of 5 feet. Repeat the timing of the floating object 3 times and record the average time traveled here. When we divide the amount of time that it's taken the ball to travel by the distance, we'll have feet per second, which is equatable to flow. To understand discharge, or the amount of water that's moving through the stream, we need to measure the width of the stream where we took our velocity measurements. Measure the width at the beginning of the tape measure where the ball was dropped, again at the middle, and also at the end of the timed segment. Average these numbers and record here. The last measurement needed for discharge calculation is the depth. Measure the depth at 1/4, 1/2, and 3/4 the stream width at each of the transects you just measured for width. In total, you will have 9 depth measurements. Average these measurements and record here. The last factor to calculate discharge is stream bottom type. Is your stream bottom rough with cobble or gravel, or smooth with sand and hardpan? Select the appropriate type here. Multiply velocity, average width, average depth, and the stream bottom type to estimate discharge. Double check your units and calculations for accuracy. Thanks for watching this video and learning the proper sampling technique. I am confident you will do well in the field, and I hope you have fun out there as well. RiverWatch cannot thank you enough for all of your efforts and determination to monitor and evaluate Colorado's waters.